statement. Then each of the things were substituted correctly, and then we isolated for this velocity. Then up here, we have conservation momentum, and then we have the initial momentum of this block right there, and then the initial momentum of this block was 0. Then we said that the final momentum of this block was 0, and then this is the final momentum of that block here. So by doing that, we can come up with a statement that describes the final velocity of this block as it flies off across. And basically, that's Vx, right? And we're going to use Vx when we finally come up with a velocity statement here that is going to be made up of two things. And one of them is going to be this self-same Vx, right? And then there's going to be one that'll be Vy, which we'll figure out that from there. And of course, we'll get theta by using inverse tangent.
Say mu to the forward.
Where? No, it's like mu and then 4mgs.
Well, 4.
Yeah. Because as Vivian caught me making a mistake where I forgot to put in that mu. I mean, the 4 kilogram mass, or whatever, 4 times mass, whatever it is. Here, do I need to write that out? Nah, you know, I'm going to keep that like that because that makes life easy. So that means Vx is equal to 4 times V1. And this here, that was V1, okay? Now, we want to find out, we know that this is a two-dimensional motion problem, so I'm going to do that in green, and we should say x is equal to Vxt, and y is equal to Vyt plus 1/2 at squared. In the y, there is no velocity yet in the beginning. Okay, so then, I should have done this with participation, but now I'm recording, so I'm doing it faster. So this, I want to solve for time because I know h, right? And so technically this is h is equal to 1/2 gt squared. And so I get a time of square root of 2h over g. So that's how long it took for it to fall. And now to find x, I can just take Vx, which is 4v1, and multiply it by the square of 2h over g. And that gives me the distance x. And then to find Vy, I don't know, there's like several different ways you can do it. Since I already know time, I'm going to use, I don't know, try to use orange, see if this works. Vy, I'll say, yeah, I know time, so it's V0 plus AT. V0 was 0 in the y direction, so that gives me the acceleration, which is gravity, times the square root of 2h over g. Right, so that's the velocity as it gets to the bottom. You could also use like v squared is equal to v0 squared plus 2ax. Yeah.
But that's only the velocity of the line.
Yes, so that's Vy. Now, I'll use the square root of Vx squared plus Vy squared. And that's going to be like whatever this giganto thing is down here with times 4. Yeah, so those two, oh, good gravy. That's a nightmare.
But why is it?
Yeah, so technically it looks something like if I square it, it becomes, and remember Vx is 4 times this, so if I square Vx, I'm going to get 16 times k d squared minus 2 mu 4mgs over 4m, and then plus the other thing is this velocity, g, this, and that's going to be g squared times 2h over g. So then this g will cancel that. So that's just using Pythagorean. And of course, theta will be equal to the inverse tangent of Vx, which is, remember, 4v1.
Oh my god!
Okay.
Wait, where's that 16 come from?
because it was the square x is 4v1 half.